a number of people. N times P is a true number of people.
Because that's the mean.
Yes.
Okay.
The mean number. And when I divide by N, like we did in the derivation that was up there, I make it into a true percentage.
Okay.
Yes.
And you need at least, like, normally it would be at least, like, I'm sure it could be, like, not just people, it could be something else.
Of course. It could be
whatever.
number of whatever it is that I'm looking at.
But it has to be greater than 5 to show.
NP and NQ
Yeah.
must be bigger than 5. The same way that N has to be greater than 30 for a problem about means, NP and NQ have to be bigger than 5 for a problem about percentages. This is just how to check to make sure that it's normal enough.
And this is based on percentages.
Yeah, because it's a percentage problem, right? So that's what builds this problem is the percentages.
Because it's 91. Because we're looking at the.
That has nothing to do with what we're talking about yet.
Oh.
91% has nothing to do with this.
So then why is this a percentage?
Oh, all right. So that first problem we did, I wanted to be 95, was it 95% confident, all right?
Yeah.
So I'm always going to have a percentage confidence. Now you've just identified something that really sucks. This problem has all kinds of percentages running around. You've got to keep it straight. The only thing this does for me, this problem, I'm never going to see 0.91 anywhere. It's going to lead me to Z. That's all that's there for, how confident I want to be. These percentages are the ones that are going to show up in the formula, right? Because they're what I actually saw in the sample. So that kind of sucks. It does. And I'm sorry. It's just, oh well. Just got to deal with it. You got to remind yourself how confident you want to be. What's the only thing that ever does gets you your Z-score. It tells you how far to go out to be that sure that you caught something. So what is that Z-score going to be? Trying to find my Z-score chart. Hey, I got one. I'm so easily amused. 0.045. So it looks like the closest I can get is here. 0.0446. I don't know if you guys got that. Hopefully nobody was going 0.05. That would make me sad. 0.045. So the closest I can get is 0.0446. It's the closest I can get to 0.045. So what Z-score is that? 1.70. Why do I not care about the negative? Because I have both of them. Yeah, plus or minus. See, so I've got both of them. I just want the number. So if I have a normal distribution, how many standard deviations do I go out to catch 91% of the information? 1.70 standard deviations out. So if I do go 1.70 standard deviations away from what I found, that should catch 91% of the data. So how certain am I that I caught a certain thing, like the real percentage? 91% certain. See how that all comes together is my hope. So now I just got to plug a chug. So I've got p hat plus or minus c times the square root p hat times q hat divided by n. And this is where people really freak out about putting it in the calculator. If you have an older calculator that when you hit the square root button, it doesn't have the bar row, it just has a parenthesis, do not close that parenthesis until you got everything in there that's supposed to be in the square root. When you close it, you're outside the square root. So if you have a little parenthesis next to a square root, next to the square root symbol, don't close it until you get all the way to 652. So you put in there 0.4847 times 0.5153 divided by 652. So I got my Z-score times the square root of all that business. So that's my error. And this is what we see. This is exactly what you see. Give or take 3%, give or take 4%. So I know this is not going to excite any of you as much as me, but we have just discovered how the shit they come up with that number at the bottom of the screen, plus or minus 4. They didn't just make it up. Let's make it 4. No, let's make it 5. I'm really not sure about what the shit we did. No, there's a mathematical place it came from. So we think we're off by about 3.3%. This is 0.4847. Give or take 0.0333. So I do my funky shit, I'd store that in x. I'd say 0.4847 minus x, 0.4847 plus x. But whatever way you do it, hopefully you get to those two numbers. So I'm going to put my little confidence interval up here. 0.4. 0.4514. Up to 0.5179. Oh, so it's going to be 80 actually. Is that cool? 4514 up to 0.5180. Now take a minute and try to write the conclusion. Ooh, let me tell you this. Your units are when you convert those to percentages. So the percentage symbol is your units on this. So convert those decimals to percentages when you put it in your conclusion. So go ahead and try to write the conclusion. It's not very different from the one from up above. We are 91% confident that what? At the interval, 45.14% to 51.8% contains the true, the true percentage of Wisconsin voters that like Gucci, no, that voted. So you have to reference the physical situation that the problem is in. You can't analyze data and say 70% confidence 2 to 7. So again, 2 to 7 is what? What's 2 to 7? What the hell are you talking about? Yes, ma'am.
What is that word? True
Percentage. Well, that's one of the words I thought I did okay with. The true percentage of Wisconsin voters that voted. All right. One more thing and then we'll take a break. Let's do this last one. Where the shit did that formula come from, do you think? Where'd that formula come from? Oh, the same place that one did. What part of this equation is E? What part of this equation is E? True. What part of it is that? This piece. So if I said E equals this, squared both sides. Sorry? You guys with me? No? You? Oh shit. Paper's not written on. There we go. So if I take N equals, okay, again, take E equals Z square root of P hat Q hat over N. And I solve for N. So I'm going to go ahead and square first because there's a whole bunch of shit that's under square root. So E squared equals Z squared times P hat Q hat over N. Is that cool? I'll just square everything. The square kills the square root. That's why these things aren't squared, because it's dead, right? And then I just replace e squared and n. I just switch those like we did before. So n equals z squared p hat q hat over e squared. That's exactly the formula I got right there. It came from the same place, just solving the error for n. So now I have a formula that can figure out how big of a sample I need. So I want to be within 2%. What goes where for that? So what's going to be the bottom of this? 0.02. Good, squared. Don't put 2 squared. You start saying I need a sample size of 0.7. What? I need one person. No. And on top, I still got my same z-score, 1.70 squared times p hat q hat. Let me make this point again. If I would have put 0.0333 in for the error, my n would have been 652. We already know that a 652 leads to an error of 3.33%. We already knew that. So can anybody tell me this n is going to be bigger or smaller than 652? Bigger. I want to be even closer. I want to have a smaller error. So of course you need a bigger sample. That makes sense. You guys knew that before you took this course. Bigger sample, better. But you can see mathematically, the math goes, that's right. And let's see, what do we get for there? 1.7 divided by 0.02 squared times 0.4847 times 0.5153. I get 1804, blah, blah, blah. Blah, 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 blah. So it's 1805. I need 1,805. So let me ask you this. How many more people do I need? That's how many people I need total. I already talked to how many people?
600.
So I need just under 1,200 more people, right? So maybe that's feasible. We already talked to 600. Maybe we can talk to another couple, 600 and 1,200 something. Maybe that's feasible. All right. I'm going easy on you because it's Monday. I'm joking. Ain't no going easy in a 4-week summer. All right. So let's take a break, because then we got one last section. Now this was 8.3. There's a reason I do 8.2 last, is because we use a different chart. We don't use a z-score chart. We use a different chart. So we're going to talk about that after the break, and then we'll do the rest of the time is going to be devoted to review for tomorrow's test. Come back at 20 past.